Hello, so in this video I'd like to go over the start of the transition work that I want to go through to help you all make the jump into year 8 after this period of disruption. So, and just as personal note, doing a little bit of work in the summer, once or twice a week for your maths will pay dividends. It is one of the reasons I managed to improve drastically in my own maths up to year 9, 10, 11. So it is a really good thing to do. So I'm really glad that you want to participate and improve your maths this way. So what I want to begin with are the building blocks of maths, which are just numbers. So this is why Unit 1 is on numbers, and then Lesson 1, what we're doing today, is on multiples and factors. And these really are the building blocks of all the whole numbers. So let's start with a definition. Multiples of a number are in its times table. So that's really easy. And we have an example. We want the first 5 multiples of 3. Well, the first multiple of 3 is the first number in the 3 times table, which is 3. And it would help if my pen worked. There we go. So 3, obviously. Second number in the 3 times table is 6. Third number is 9, 12, then 15, and so on. So the first 5 multiples of 3 are just these numbers, the first 5 numbers in the 3 times tables. Very, very easy. Now, common multiples are numbers which are multiples of more than one number. So they are numbers which are in not one, but 2 or possibly more times tables. So we have an example. We want a multiple of 4. We want a common multiple, sorry, of 4 and 3. So we just look at the times tables. We look at the multiples of 4 and 3 and see which ones they have in common. You know, if you and I have a friend in common, we share a friend. They're a friend of both of us. So we look at the 4s. So 4. So these are all the multiples. These are the multiples of 4. So 4, 8, 12, 16, 20, 24, and so on. We look at the 3s. 3, 6, 9, 12, 15, 18, 21, 24, and so on. Now, we can see there are a number of common multiples here. First of all, we have 12. We can see 24. If we carried on, there'd be a whole number more. So I know 36 is in 3s. 3 times 9 is 36. Not 3. Yeah, 3 times, sorry, 12 is 36. And then 4 times 9 is 36. So we could also say that 36 is a common multiple. But 12 is special. 12, and you may remember this, is the lowest common multiple. And we write that, because we use it so much, we write it the LCM. So 12 is the LCM of 3 and 4. And that is really important. We use that in lots of problems. Excuse me. So we have some questions on multiples here just to get our brains in gear. We want to write down the first 5 multiples of 6. Then we want to work out the lowest common multiple of 6 and 8. And I started you off with the times tables. And then for question 3, I want you to circle which of the numbers in the list are not multiples of 5. So pause the video, have a go, and then when you're ready for the answers, please press play. So let's go through the answers. So the first 5 multiples of 6, we are looking at the first 5 numbers in the 6 times table. So that's going to be 6, 12, 18, 24, and 30. Those are the first 5 multiples of 6. Secondly, we want the lowest common multiple of 6 and 8. So we just consider the multiples of both numbers. So we have 6, 12, so for the 6 times table, 6, 12, 18, 24, 30, 36, and so on. For the 8s, we have 8, 16, 24, 32, 40, and so on. And we can see that 24 is the smallest number in both of the lists. So, you know, we could go on with the 6s. You could have, so we could go up to 36, then 42, and then 48, And obviously there's 48 in the 8 as well, and you can see 48 is a common multiple, but 24 is the lowest common multiple. So we can say the LCM of 6 and 8, we write it like this, LCM bracket 6, 8, is equal to 24. Rather straightforward. And then question 3 finally, we want the numbers which are not multiples of 5. So if we consider the 5 times tables, we have 5, 10, 15, 20, 25, 30, and so on. Now we can see that 10 is in the list, 15 is, 20 is, 5 is, so all of those are multiples of 5. Well, 24 isn't in the list, so it isn't a multiple of 5, nor is 1. And 1, people often make the mistake and say, well, 1 times 5 is 5, but 1 is not a multiple of 5. It's actually something else. It leads us into the idea of a factor. So just bear in mind, 1 is not a multiple of 5. So with that in mind, let's actually look at what a factor is. So factors of a number divide it with no remainder. Now that might sound a little bit, bit of a, bit of a formal definition, but it's really it's nice to illustrate it in real life. So if we imagine that we had so if we imagine that we had 6 sweets, so 1, 2, 3, 4, 5, 6. Now imagine I want to split up my 6 sweets into groups of 2. Well, I can do that exactly 3 times. I could make 3 groups of 2. So I can say what I've really done there is said that 6 divided by 2 is 3. We can do that. In fact, I'll leave that on there actually. So we can do that. Or we could do, so let me just go into eraser mode. There we go. So we can also say that, what if I wanted to split into groups of 3? Well, we could do that as well. We could have 2 groups of 3. And what we've done there is we've said that 6 divided by 3 is 2. We could also, and this is probably the easiest case, we could also divide them into groups of 1. We have 1, 2, 3, 4, 5, 6 groups of 1. So we can say 6 divided by 1 is 6 because we make 6 groups out of it. Finally, what we could do is say, that we have our 6 sweets, and we can say that we have 6 sweets, which is the same as saying that there's one group of 6. So we can say 6 divided by itself is 1. Are there any other ways to group my sweets into? So can I group them into any other amounts? Well, I can't actually. So without leaving remainders. So we can say that the factors of 6 are 1, 2, 3, and 6. Those are the numbers which will divide 6 exactly. So I've also got an example here. So 1, 2, 4, and 8 are factors of 8 because 8 divided by 1 is 8. So that means that 1 will divide 8 with no remainder, 2 divides 8 with no remainder, and 8 divides 8 with no remainder. But how do we know that we've listed all of the factors of a number? Well, to do that, we use the horseshoe method, which is some people call this the bucket method. I like to call it the horseshoe, and you will see why very shortly. So we want to list the factors of 12. This is our method. We begin by writing 1 times 12, and as I said earlier with 5, 1 is a factor of 5, and it's actually a factor of all whole numbers. So 1 times 12 is 12. And then we imagine that we're going up the list of whole numbers. So 1, 2, 3, 4, and so on. And we're seeing each time if they are factors of 12. So let's try 2. Well, 2 times 6 is 12, and this is all to do with how well you know your tables, really. 3 times 4 is 12. And then I go to 4 because I've just done 3. So obviously now I'm going to be at 4 times 3 is 12. Now, I've put that in a different color because we have now repeated a factor pair. We have repeated 3 and 4. So once we have a repeat, we stop. Once we have a repeat, we stop, and I like to put all of the other factor pairs in this nice horseshoe. And then we can actually read off the factors really nicely. We can see the factors are 1, 2, 3, 4, 6, and 12. So we can say the factors of 12 are, so 1, 2, 3, 4, 6, and 12. Those are all of the numbers which divide 12 exactly. So if we had 12 sweets, we could produce 12 groups of 1. We could produce two groups of 6, or 4 groups of 3, or we could say 3 groups of 4, and so on. So these are the only numbers that divide 12 exactly. So as before with common multiples, a common factor of two numbers is a factor of both of the numbers. So if we want to work out the common factors of 8 and 12, we first look at the factors of both numbers. So, if you want a little exercise, you could pause the video, have a go writing the factors down yourself first. If not, we'll just go through them now. So if we look at the factors of 8, we have 1 times 8 is 8, 2 times 4 is 8, and then, 3 is not a factor of 8 because 8 is not in the 3 times table. So we're going to have to go up to 4, but when we get to 4, we have 4 times 2, which is a repeat. So now we can stop. We know we have listed all of the factors. So we have 1, 2, 4, and 8. So I put them in the curly braces to show that it's a set, and we can say that that set is the factors of 8. Similarly with 12, so 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12, and then we have 4 times 3. But again, we've repeated, so our factors of 12 are going to be 1, 2, 3, and you can see how I'm reading. I'm going down this end of the horseshoe, I'm going this way, and then going up. 1, 2, 3, 4, 6, and of course 12. So I ask you, which number is in both of these sets? Oh, which number is in both of these sets and is the largest? Well, we can see that 4 is in both of the sets, and it is the largest number in both of the sets. So we say that 4 is the highest common factor of 8 and 12. And again, we use this so much, it's really important, particularly in things like cryptography, so keeping passwords safe online, things like that, that we actually call this the HCF of 8 and 12. Little acronym. And in America, you will see, you'll also see GCF, which is greatest common factor, because greatest is really the same as highest. Maybe the English teachers will disagree with me there, but I think they're pretty much the same word. And you'll also see GCD, because D means divisor, and it's another word for factor. So lastly, this leads us on to the idea of prime numbers. Now, these are incredibly important. This is why we call them prime. You think Amazon Prime, you're an important customer if you've got Amazon Prime. Prime numbers are very, very important. But all we need to know now, really, is a prime number only has factors of itself and 1. Now, I may make a video on the sieve of Eratosthenes, which is a really cool way of generating the prime numbers. But for now, just be aware, a prime number only has factors itself and 1. So the first 5 primes are 2, because the only factors of 2 are 1 and 2. Then 3, only factors of 3 are 1 and 3. Just think, can you think of any numbers besides themselves and 1 which go into these numbers? You won't be able to. 2, 3, 5, 7, 11, those are the first 5. And there are loads of really fascinating properties of primes which I haven't got time to go into now, sadly. So with what we've done so far, you should be able to have a go at the questions 1, 2, 3, and 4. So the aim now is for you to have a go at the questions, pause the video and then press play when you're ready for the answers. So here are the solutions. So so write down any three multiples of 4. So I've said 4, 16, 32. Those are all numbers in the 4 times table. For the 9s, I picked 18, 27, 81. And for the 15s, I picked 30, 45, and 60. You may not know your 15 times table. That's fine. Just write down 15. And then, well, 1 times 15 is obviously 15. 2 times 15 is going to be the second number in the 15 times table. And we know that's got to be 30. You know, double 10, we get 20. Double 5, you get 10. You add them, we get 30. So you can generate the 15 times table like that to get your numbers there. All the factors of 30, so 30 has loads of them actually. So it's 1, 2, 3, 5, 6, 10, 15, and 30. Factors of 44, 1, 2, 4, 11, 22, and 44. Factors of 28, 1, 2, 4, 7, 14, 28. And in every case, I've used my horseshoe method. So if you're not entirely sure, have a look back, see if you can generate the factors in the same way. 15, 1, 3, 5, and 15. From the numbers in the box, a factor of 35, well, 7, because 5 sevens are 35. So if you're not sure of that, do practice your 7 times table, or just practice your tables in general. I think it's a really good thing to wake up, practice your tables every day. Write the multiple of 20, 40. The smallest odd number in the list. So an odd number is a number which is not in the 2 times tables, just to remind you. So the smallest odd number in that list is obviously 3. An even number bigger than 50, well, 62. And in fact, that's the only one you have there. 2 numbers that add to 80, 57 and 23. So how do you do on these questions? I'd say if you manage to get at least 3 of the questions, so 1, 2, 3, and 4, if you manage to get at least 3 of those completely correct, you could be a green. If you if you just had 2 of the questions, be just 1 and 2 correct, you'd be an amber. If you've got less than 2 questions, rate yourself a red, but don't despair. Just have another look for the video, and if you're not sure, just ask me on Teams or on the forum, and I'll be glad to help you. So, lastly, we're going to look at some real-life problems, because I know this seems like really abstract maths, doesn't it? It seems like this is something you'd never use in real life. But you actually do use it in real life. I mean, computer programmers will use it to work out methods of encryption, so keeping your data safe online, although you have to be really careful with that as well. You've got to be careful what you put online. But really, you also use it in sort of real-life questions like this, particularly in things like music, when you want to time different instruments coming into a piece of music. So you'll use the lowest common multiple for that. But we're going to look at 2 real-life problems to help you with the questions that I'm going to leave you to do ready for Thursday. So the first one, so question 1 I'll call it. Liz has 2 pieces of string. One is 18 centimeters long and the other is 24 centimeters long. She wants to cut them up to produce smaller pieces of string that are all the same length with no string left over. What is the greatest length in centimeters that she can make them? If you want to give this a go on your own, just pause the video, try it, and then see what I get to. That's a really good way to revise, actually. So when we used to have the old Maths Watch videos when I was in school, that's what I would do. So, but if we just go through this now, we have one piece of string which is 18 centimeters long. So I'm just going to do a little picture. This obviously isn't going to be to scale. Another piece of string which is 24 centimeters long. So what Liz wants to do is cut them up into smaller pieces, producing pieces of string that are all the same length. So when we read the word cut them up into smaller pieces, we really should think of dividing the string. So we could divide the 18 centimeters, we could divide it into units of 2, couldn't we? We could say we have 9 lots of 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so we could say that each of these little blocks is 2 centimeters long. We could do the same thing with the 24. We could say, 1, 2, 6, 7, 8, 9, 10, 11, 12, and we'll just ignore that bit, we'll pretend that bit isn't there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we basically have the first one, the 18, is made up of 9 groups of 2, and the 24 centimeters long one is made up of 12 groups of 2. So we could do that, and we can see that the so we can say that in both cases we have the same length of string for each of the pieces, and there's nothing left over. But is that the greatest length that we can make each of these pieces? Well, if we think about it, what we've really done is we have divided 18 by 2 to get 9 pieces. We divided 24 by 2 to get 12 pieces. And 2 is a factor of 18 and 24. So we've looked at a common factor of 18 and 24 too. But what we have said, but what we need here is the greatest length that she can make them. So we need, because 2 obviously isn't the greatest length that we can make them, we need the highest or the greatest common factor, because obviously 2 is a factor of a common factor of 18, 24, but we need the highest common factor of 18 and 24. So to do that, we're going to need to consider the factors of 18 and 24, as we did before. So we have 1 times 18, 2 times 9, 3 times 6, 4 doesn't go, 5 doesn't go, 6 does go, but then we have a repeat. So the factors of 18 are 1, 2, 3, 6, 9, and 18. The factors of 24, 1 times 12, 2, no, that's completely wrong. 1 times 24, 2 times 12, 3 times 8, 4 times 6, and then we have a repeat. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. So which number is the biggest number in both of these lists? Well, we should be able to see that it is going to be 6. 6 is the highest common factor of 18, and 24. So that means, so I would say HCF of 18 and 24 is 6. So the largest or the greatest length in centimeters that she could make each of the pieces would be 6 centimeters. And if I can, I will just briefly demonstrate that to you. Okay, so I've got a ruler here. So what I'm going to do is draw. So I'm just going to draw a line which is 18 centimeters long. So I'm going to try and do it to scale on the board. So 18 centimeters. And then what I will do is draw a line which is 24 centimeters. And what we want to do, so we've claimed that 6 is the highest common factor. So if I divide them both into lengths of 6, so let me get a different color. So 6, 12. We can see that in both cases, we can do it with no remainder. So 12 and 18. So we have 3 lots of 6 for the 18. And then for the 24, we end up with, so let's do that, 24. We get 6, 12, 18. And then there's the other one there, which is 6 centimeters long for the last one. So we can see that in both cases, we end up with lengths of 6 centimeters. As so there. So that does work. So whenever they're after the greatest length or the greatest amount of something, and it's clearly a types of number question, think of the highest common factor. The second one, we have Helen is organizing a party and she needs party plates and straws. There are 30 party plates in a pack, and there are 120 straws in the pack. She needs exactly the same number of plates as straws. What is the minimum number of each pack that she must buy? Now, the way we should think about that is, so what is the minimum number of packs she must buy, number of each pack she must buy? This time we should be thinking of the word least, so least common multiple. So there are 30 party plates, 120 straws. It's exactly the same number of plates and straws. So what is the minimum number of each pack that she must buy? So she needs the same, obviously. For every plate, she needs straws. So if we look at the party plates, if she buys just one pack, she can have 30 plates. If she buys two, she's going to have 60 because there's another 30 in that other pack. If she buys three, she gets 90. And if she buys four, she gets 120. Now, there are 120 straws in one pack. So if I consider the first one plates, second one straws, so if she just buys one pack of straws, she gets 120. Well, we can see that 120 is the lowest common multiple of 120 and 30. So that means she must buy 4 packs of plates to get 120 and just one pack of straws. So the working would be that the LCM of 30 and 120 is 120, and that 30 times 4 is 120, and 120 times 1 is 120. So those are some examples of some real life problems. And what I'm going to do, just to conclude the video, I'm just going to mention that I've put some questions for you to do up on Teams and also on the forum. And what I would like you to do is try the questions ready for Thursday. And then on Thursday, we'll go through the answers. Now, if there are any problems, just let me know on the forum or on Teams. I'd be glad to help you.